By now, the colors should be put away. We're on page 12. Dmitry Mendeleev, guys, I'm talking. Hush. Dmitry Mendeleev, we just watched a video about him, the first person to organize elements into a table. He put them in order by atomic mass in rows and chemical properties in columns. Then, about 100 years later, a guy named Henry Moseley comes along. And he updated the periodic table. The one that he updated is basically the same one we use today. Like right now on the back of your pink book, this is the one that Henry Moseley created. It's just, we've discovered more elements since then and we've added on to it, but we're using the same stuff he used. We put them, Henry Moseley put them in order by atomic number in rows and by chemical properties in columns. And the reason that Henry Moseley could put them in order by atomic number is, and Mendeleev couldn't, has to do with technology at the time. If we're putting stuff in order by atomic number, what part of the atom are we putting it in order by? By what atomic number tells us the number of protons. So Henry Moseley was able to put them in order by atomic number because technology had continued to where we knew what protons were. Whereas when Mendeleev was working 100 years earlier, we had not discovered protons yet. So he did not know about them and couldn't put them in that order. We also need a couple definitions here. An ion, I-O-N, is an atom that has unequal protons and electrons, which means it has an overall charge. If it has unequal protons and electrons, that means the protons, what charge do protons have? Positive. And electrons are negative. So if they're unequal protons and electrons, that's unequal pluses and minuses. So you're going to have an overall charge that's not zero. One type of ion is a cation. It is an ion that has more protons than electrons. If it's got more protons than electrons, is that going to be, what kind of charge is it going to have if there's more pluses than minuses? Positive. Okay? Yes. Yes. How does it end up with more protons than electrons? What happens is, the number of protons can't change. Because if the number, Ray, are you writing or are you talking? Okay, do it without talking. The number of protons cannot change because if it did, that would turn the atom into a different element. If the number of protons changes, it would turn into a different element. So if the number of protons is the same and the number of protons is bigger than the number of electrons, what does that mean happened to the number of electrons? Like, we start with some number of protons, and we start with the same number of electrons, but then later, when the ion forms, there are more protons than electrons. So, what does that mean happened to the electrons?
They stayed the same. They disappeared. Wait.
The protons stayed the same, and the electrons...
Oh, then they got less.
Yeah, got less. So they went down, or you could say we lost some electrons. I wouldn't say disappeared. They don't stop existing, but they leave. Oliver, do you have a question?
No.
Oh, because you were making a lot of noise, so I thought you might have a question. Okay, I'm glad you're writing, but why are you making so much noise?
What noise?
Why are you asking her about her dad's name? That's not what we're talking about right
No,
now.
you have to know the...
No, I don't have to know the full story because there should be zero story, Oliver. Oliver, hush. Do I need to move you to your own special table where there's nobody you can talk to? Prove it.
Billy, what's her dad's name?
No, Gabriel, not helping. Hush.
Curious now.
Hush. Okay. The other kind of ion is called an anion. Anion. This is an ion that has more electrons than protons. So if there's more electrons than protons, there are more negatives than positives. What kind of charge is it going to have? Negative. How does it end up with more electrons than protons? Well, if the number of protons changes, that would be a problem. It can't change, because if the number of protons changed, the atom would become a different, what? Element. So if the number of protons is the same as it started as, but there are fewer protons than electrons, what happened to the electrons? They went up. We gained some. Okay, I want to say a couple quick notes about cations and anions. Okay, first of all, say this word out loud, cation. Say it again, cation. This is a compound word. You know how you don't pronounce this word? Don't say cation. Okay, you sound like a moron. Don't say cation. This word is not cation. This word is cation. It is a compound word. Okay, and this word right here, anion. Say it, anion.
Anion.
Say it again, anion. You know how you don't pronounce this word? If you say anion, you sound like a moron. Stop. Say anion. This is a compound word. Anion. Davenport, you sound like a moron. Quit saying anion. Okay, and I've got a trick to help you remember which one's positive and which one's negative. Are you ready for this? It's super dumb. I'm going to show you a dumb trick. Here you go. Hush. Look. Watch. Watch. Face the board, Oliver, and watch. Cations are positive, and if you look at the word cation, the T is like a plus sign, telling you it's positive. And if you look at the word anion, the capital A has this crossbar, that's like a big minus sign, telling you it's negative. Good. Okay, so cations are positive, the T's like a plus sign. Anions are negative, the A has a minus sign in it. So that's how you can remember which one's which. All right, we have a chart to fill in. We have a chart to fill in. These are for the families of the periodic table. Remember that a group and a family are the same thing. Those are the columns. Hush, ladies. Okay, and if you recall, real quick, turn back to page 10. Your page 10 should be done already, but turn back to it real fast. I'm gonna show you a trick. Okay. Yeah. Yeah. If it's done, you can bring it to me and I'll stamp it. Okay. Listen. Hush. Gabriel, hush. Micah, Richard, Will, hush. I heard noise coming from the three of you.
Hey, you gotta use that.
I know Micah was talking. I'm sorry, Richard, if you were not.
Yeah, Richard, you always.
Hush. Ethan, stay out of it. Stay out of it.
Calm this boy down.
Okay. Here's a trick to remember which ones are periods and which ones are groups or families, okay? If you write the word period, you can write the P really long. Okay? Because the periods are the across ones, the rows. Okay, that can help you remember that the periods are the rows. And are you talking or are you listening? Richard, this time you are talking. Hush. Okay, the groups you can write with the really tall G, and a family you can write with a really tall F. To remind you that those are the up and down ones. Those are the columns. The columns have two names. They could be families or groups. It is a big G. Okay, if you draw them like this, that might help you remember which one's the rows and which one's the columns. Okay, you have a long P in the period. You have a tall F and a tall G. Tall F and G. All right. Columns? Yeah. Okay. So, knowing that, columns. Knowing that, let's go back to this chart. Remember that groups and families are the same thing. Those are the columns. And we're going to talk about group 1A, meaning the very first group on the periodic table. Let me see the two papers. Good, thank you. That's the only answer. Bring it to 2. Gabriel.
Not the one that you gave me, not the package you gave me. Going from the yellow book.
Yeah, bring it to tutoring. We'll go over that too. Gabriel, I have a question for you. In the coloring activity, we learned the name of that first group. What is that first group called? You're close. Alkali. Alkali metals. Okay, alkali metals. Alkali metals are, and we watched that little video with the explosion. Alkali metals are furious. Okay,
So for New Year's,
Oliver.
throw a bunch of alkali metals in the river.
No, that's a bad idea. Do I need to move you? Okay, you guys are making noise. And I'm pretty sure that, okay, you should not be talking at all. Okay, but do good quietly.
Hey, it's better than me doing this and not even doing anything.
I agree, but do it more quietly. Gabriel, Max, and Sam Ortiz.
Yes.
Do I need to separate you three?
No, ma'am.
Prove it. Hush your mouths. Quit flipping that water bottle. If you flip it one more time, I will smack you in the head with it.
Actually, that would be child abuse.
No, you're not a child. Okay. Alkali metals are really, really reactive.
My mom used to know.
Davenport, hush.
That wasn't me.
Whoever it was. How many valence electrons do alkali metals have? Do you remember how to tell? Check your periodic table. The alkali metals are this first group. And that one at the top tells you there is one valence electron. So in one of these boxes, you're going to put a 1.
Wait, what's the valence electron again?
The electrons on the outside of the atom.
How do you find that?
By looking at the periodic table, whatever column the element's in, the number at the top tells you how many valence electrons there are. Because we're going to draw something in the other 3. Ray. Oliver. Hush. Ethan, sit down. Gabriel. Why don't you move? Why don't you move to this desk over here?
Gabe didn't say anything.
Well, then he's getting punished for you two making noise. I know that's not fair, but maybe you should have hushed before your friend got in trouble. Hush. Okay. When we draw alkali metals with their one valence electron, we just put the 1 dot on it.
Oh, those are examples, aren't they?
Yes, they are examples.
I'm smart, I figured it out.
Clayton, do you need something? Hush. Do you need something?
No, I just cut myself with a wire.
Oh, what were you using a wire for? Why was
Making
there a
a
wire to
tree.
cut you?
And
You
not
should have been. Oh, you mean it
Well,
earlier?
like I used your hand sanitizer and it hurt me.
Oh, yes, hand sanitizer would sting a cut. Oliver, Max, hush. Okay. What is group 2 called? Again, this is something we just learned when we were coloring earlier. These are the alkaline earth metals. Notice there are more letters here. Alkaline
Hey, I use that stuff.
earth metals. Davenport, hush.
Why couldn't they just name these elements like Bob elements or something? Why do they have to use like?
Well, this word alkali means basic, so they're like acids and bases. They're bases. They form bases. So that's where this word came from. Okay. Alkaline earth metals are not furious, but they're kind of grumpy. They're kind of grumpy. Okay, and they are reactive, but they're not as reactive as the alkali metals. How many valence electrons, Leah? Leah, how many valence electrons do alkaline earth metals have? Do you know how to find out, Leah? Okay, well, what you do is you go to your periodic table, you find the alkaline earth metals, which are this group right here, and that number at the top tells you how many valence electrons there are.
So I have to find out.
The number at the top of the column, look where I'm pointing.
So 2?
Yes, that's it. Okay, and when we draw those, they each have 2 valence electrons, so we draw 2 dots. Shh. Hush.
In your copy, you were.
Yeah, as long as they're 90 degrees from each other. Okay, group 7A, we just learned a name for these guys as well. In the coloring page. Yes, Ilana? Yes, you actually pronounce it halogens, but yes, halogens. Halogens. Yes, exactly like a halogen light bulb. These elements, no, not like that.
Yes.
These elements are the ones in halogen light bulbs. Okay? Halogens are also furious.
That doesn't look like
What about Diablo?
Well, then draw an angrier person. If you don't like my drawing, draw an angrier person. They are ridiculously reactive.
Are they more reactive than alkali?
They're on par with that.
Ridiculously reactive.
Okay, if you find the halogens on the periodic table,
How are we gonna do group 8?
we'll get there. Chill.
No, but look
Oliver, we're not there yet. Chill.
at my paper. It's like bent.
It'll be fine.
Okay.
It'll be fine.
It'll be.
Okay. How many valence electrons do the halogens have?
Hold on, let me try to figure that out.
Okay. They're the second to last group over here, where fluorine is.
7.
So they have 7 valence electrons. Thank you, Leah. Good job. So when we draw those with 7 dots, we put 1 on each side. Then we go back and pair them up.
Still very bad.
Hannah, put your phone down.
That's a lot.
Davenport, hush. Okay, there are a couple different ways you could draw them, but each way they've got 7 dots. There's always 3 pairs and then 1 left over. And our last group, the 8th group, Davenport, what's the last group called?
The noble gas.
Yes, those are the noble gases. The noble gases, they're called noble because they don't react with anything else. They're too good for the rest of the periodic table, just like nobility. Too good, too good. They don't react. Okay, they are stable.
Stop it.
Oh, that's so cute.
Thank you.
Whenever they said noble gas, it's always made me think of Noble Team and Halo Reach.
Always?
Yep.
That didn't exist that long ago.
Well, I did when I learned about it.
Okay. They are unreactive, or we have a new word for that that's called inert. They don't react.
Raylo Beach.
Shh. Okay, guys, quit talking about halo. That's not even how you pronounce this word. It's halogen. If you want to talk about halo, do it outside of my class.
1v1.
Hey, what are those for? You weren't like.
I will talk to that after outside of class.
Just call me a
Right now, I'm talking about this. Duh, look around my room, Leah. Okay. How many valence electrons do the noble gases have? They have 8, except one of them,
Hydrogen,
not hydrogen,
close enough.
except helium only has 2 valence electrons because helium only has 2 electrons total. So 8, except helium has 2. Okay, you could draw helium 2 different ways. You could draw it like this, which would be the normal way we draw it. But because helium's, those are its only 2 electrons, they do actually pair up. So you could also draw helium like this, but that's the only one that you could draw with just 2 dots and them be next to each other. All the other noble gases like neon and argon and krypton, their 8 dots would make them look like this. When you're finished drawing that, go to the top of page 13, next page. You have 10 seconds to catch up to me and then I'm moving my paper. Alana, do you have a question? All right, next page.
Are we just taking notes today?
Yeah.
Okay.
Children, hush.
Oh, you just said that we're not children.
You're acting like children right now. Hush.
I'm not. I still got moved.
Yeah, you're doing better now that you're over here.
No, I was writing them down over there.
Sam, hush. Not you, sorry.
Oh, dude.
He's like the question.
Should I switch you with Gabriel?
No, I'm good.
Why don't you prove it?
Sorry.
Don't apologize, just be quiet. Okay. Elements, atoms need to be stable, and only the noble gases are stable. So they will try to get what's called a full octet, meaning they will try to look like a noble gas and be stable with 8 valence electrons. And to do that, they're going to have to either lose or gain some electrons. So if we look at this first group, lithium right now has 3 total electrons. One of them is valence. And to look like a noble gas, it can lose this 1 valence electron, and then it'll look like helium. So it's going to lose 1 valence electron. And when it does, it's going to look like this. So it starts with 3 electrons and 3 protons. So we're going to draw some pluses and minuses. It starts with 3 protons and 3 electrons. Oliver,
Sorry.
if you were sorry, you wouldn't keep doing it. Okay. It starts with 3 protons and 3 electrons. How do I know that? How do you know how many protons it has? It's the same as the electrons from the atomic number on the periodic table. Okay, at the end, the number of protons has to stay the same, but now, how many electrons does it have? After it lost this 1, how many electrons does it have now? 2. It only has 2, which means there's a leftover plus here. So it's got an ionic charge of +1. What kind of ion is it if it has a +1 charge? Is it a cation or an anion? That is a cation. No. Noah, go sit down.
What?
Go sit down. It is a cation. Okay, this thing right here, this is an ion. You could draw it in brackets like this and put a +1 outside to show it's got a charge, so it's an ion. Okay, and look at the radius of this atom. Before, what does radius mean? Distance from the middle to the edge, the center to the edge. Okay, look at the radius here. Lithium started with the radius like this, and now its radius is just this much. So the radius got smaller. Why? Because it lost electrons. When you lose stuff, you get smaller. That's why people diet, right? If they lose the pounds, they lose the fat, they get smaller. That's very important to some people.
And when they get bitten in half by a crocodile, they get smaller.
Okay, that's not helpful, but you're right. Okay?
Crocodile. No, he's talking about.
Ethan, Dylan, hush. Okay, alkali metals are soft and they are easy to cut. You can actually cut them with a butter knife. They're a metal that you could cut with a butter knife. And as we saw in the video, they explode upon contact with water. Leah, do you have a question?
Keep looking at me and laughing.
Okay, Leah, leave Ethan alone.
I wasn't meaning to say that. I was just like laughing at what you said.
Okay,
I don't know what's going on.
get control of yourself. Ethan, don't worry about it.
I am an idiot.
Okay, alkaline earth metals, meanwhile, if we look at this picture, what, you weren't done? Get on my level.
Alright, we're good now.
Alkaline earth metals want to look like a noble gas. And to do that, they will lose 2 electrons because they have 2 valence electrons. So this one and this one will go away. Question, Noah?
What element in water causes the metal to explode?
It's not one or the other element, it's the compound itself. It's the molecule itself. Yeah. And it's more about the alkali metals. They are so eager to give away this 1 electron that because it releases a lot of energy when they do, so they are able to give their 1 electron to the water molecule, and that releases a lot of energy, which is what causes the explosion. Davenport?
So salt is sodium, right?
Yeah.
Like, so if I were to pour like salt into water,
That salt is not solid sodium. Salt is sodium chloride. Hey, hush. We are supposed to finish not only this page, but the next 2. And I don't think we're going to get there because I keep having to tell you guys to hush. Shut your precious mouths so we can finish. Group 2, these elements, these atoms lose 2 electrons. And when they do, you get something like this, where beryllium now only has this 1 shell. How many protons, if you look at your periodic table, how many protons does beryllium start with? What is the atomic number of beryllium? 4. So it starts with 4 protons. And it starts with 4 electrons. We can see that in this picture. At the end, it still has 4 protons. But after it lost those 2 outside valence electrons, now how many electrons does it have? 2. Which means, if you look, there's 2 leftover pluses here. So what kind of charge are we going to have? Positive 2. That means this is an ion with a +2 charge.
Would that make it a cation?
It is also a cation, yes. Having a positive charge makes it a cation.
Whoever said cation is permanently burned into my brain.
I'm sorry to hear that. Try to unburn it. Okay, how did the radius get when it lost these 2 electrons? What happened to the radius when it lost these 2 electrons? Did it get bigger or smaller? It got smaller. Why? Because it lost electrons.
So what's the electron?
Okay. Alkaline earth metals have some physical properties of being not really hard, but they're not as soft as the alkali metals.
So butter, basically.
Micah, do you have a question?
So basically, really cold butter. Like butter is
Slightly harder, yeah. Okay, alkaline earth metals are also reactive. They will react with water at high temperatures. They will explode with water. At room temperature, they won't really do anything, but at high temperatures, they will explode with
Throw it
water.
into a hot spring.
Yeah. Okay. Group 7A, now the halogens. Remember, the halogens, just like everything else, they want to look like a noble gas. And the halogens already have 7 valence electrons. And to look like a noble gas, they need 8. So what do you think the easiest thing is for a halogen to do? Gain 1. So if we look at fluorine, for instance, it starts with 7 protons and 7 electrons. But when it gains 1 electron, Clayton, hush. Okay, here's what it started out looking like. When it gains 1 electron, now it has 8 valence electrons. There's an extra one here. And that means we have 7 protons. 6, 7. And now there are 8 electrons. So if there's 8 electrons, that means there's this leftover electron up here. So that's going to give us a -1 charge. What kind of anion? Oops. What kind of ion is that?
anion.
That's an anion.
Anion.
Anion. Okay, if it gained 1 electron, do you think it got bigger or smaller? If you gain something, you get bigger. Okay, halogens, at room temperature, fluorine and chlorine are gases, bromine's a liquid, iodine and astatine are solid. Their chemical properties are that they are always diatomic. What do you think this word diatomic
We
means?
can't see dynamite.
Oh. What does the prefix di mean?
Like to, or two?
2.
Oh.
So diatomic means 2 atoms.
Get rid.
They're always in pairs.
Oh my god.
Okay, so it's F2, or it's Br2, or it's Cl2, or it's I2. There's always a 2. Okay? You better hurry. I'll move it back to the bottom in a second. I'll move it back anyway. We're gonna do the top part. Okay, group 8A is a noble gas, so it's already stable. It's gonna lose and gain 0. So there is the same number of electrons and protons before and after, because there is no after. They're not going to change. They're not going to react. So that means it's got 8 protons. Neon has 8 protons. 1, 2, 3, 4, 5, 6, 7. And neon has 8 electrons. So the charge is 0. And it is not an ion. It is not an ion, which means the ionic radius doesn't exist because it has the same number of electrons. Okay, at our physical properties, noble gases are odorless and colorless gases, and they do not react. What does that mean, odorless? There's no smell. They don't smell.
So if you were to put a whole bunch of argon in this room, you would not smell
You would not be able to smell it.
What about see it?
You would not be able to see it.
So how do you know that we're not in a whole bunch of argon right now?
You're not suffocating?
That's true.
Yeah, it is true. When you're done, turn the page.
Oh my goodness, which was this so bad.
What, Oliver? Yeah.
Actual chairs in
It's
this
just
place.
the same thing that's shown right there, right?
For neon?
Yeah.
Yes. Okay, I'm going to turn the page. I hope you're done. Okay. The atomic radius is the normal size of something. If you look at beryllium, it's going to lose 2 electrons. Whoops, this should be a positive. Change this to a positive up here. That's supposed to be a positive. That's a typo. Fix that. Question?
Where does the gas come from?
Where does the gas come
Is there like
from?
a gas tank underneath us?
No, there's like pipes that go from one of the other buildings. No, it's not propane, it's methane. Okay, if they lose 2 electrons, that means they lose negatives. And if you lose a negative, if you subtract a negative, what does your charge become like? It's going to be positive, right? If you want to be a positive person, you got to lose all the negativity in your life. Okay? If you lose negatives, you're going to get positive. When you lose 2 electrons, the radius is going to be smaller because you lost electrons. No, thank you. No, thank you. I don't, no, thank you. Hurry. Okay, there's some blanks to fill up here. Atomic radius is the size of a neutral atom. The normal size with the same number of protons and electrons as the periodic table. The ionic radius, Davenport, are you writing?
Yes.
It doesn't look like it.
Exercising all.
Do it by writing. Ionic radius is the size of the ion when it has lost or gained electrons. It will get smaller or bigger than the normal atom. It will get smaller or bigger than the normal atom. Okay, for fluorine that has 7 electrons, to look like a noble gas and be stable, it will gain 1 electron. Which means when it gains a negative, that charge is going to be -1. And it's going to look like this. And if it gained an electron, Oliver, is it going to get bigger or smaller?
Wait, don't.
Bigger, yes. Why? Why is it bigger?
Because you said.
What happened? What happened to make it bigger? What happened to make it bigger?
It gained 1.
It gained an electron.
Let's
Yes.
freaking go.
Okay. There are some practice problems at the bottom here that you are supposed to try by yourself. Yes, I'll move it. So these problems you need to do by yourself.